Hi, my name is Jamie Bradford. I'm in Geography of Michigan 345, and this is my midterm exam. The first question asked on the midterm is discussing the Richard Morel article, where he outlines how space is related to geography. He argues that space is always optimized, whether it be subjectively or not. The question for the midterm is asking whether or not the physical geography of Michigan has made that optimization easier or more difficult. And my argument to this question would be that it's both. First, I'll outline how it made it easier, then I'll outline how it made it a little bit more difficult. So basically, it's made it easier because we have resources. We have the Great Lakes, which made transportation much easier. We have large mineral deposits, like in the western upper peninsula. We have large iron ore and copper deposits. At one point, Michigan had a vast white pine forest. We have all sorts of deposits, mineral deposits, like limestone, dolomite, halomite, gypsum, coal in the Michigan Basin. We have so many natural resources that have made our optimization of space much easier. When Michigan was an early frontier, we had vast amounts of space, which allowed us to enter into the free market economy, eventually becoming part of the industrialized nation as a whole, allowing us to utilize some of these resources like the Grand River and the logging and all of these things to help build our Michigan economy, eventually becoming what it is today. And that is specifically because we were able to optimize the resources we had readily available to us. Now, when Michigan was a frontier state, it was very difficult to travel through. Michigan was swampy and had mud holes and had mosquitoes. We have mosquitoes today, but we have bug spray. I mean, this was much more difficult to travel by horse and wagon. Transporting materials, say you cut down, a white pine forest in the Upper Peninsula, you still had to transport those materials to other places in the industrialized nation. Otherwise, they're worthless. So what if you have a giant iron ore or copper deposit up here? If you can't get that iron ore anywhere, it's just a big rock. It's useless unless you can get that transported, and it wasn't always easy in the state before railroads or the automobile. So in that aspect, I think that the physical geography of Michigan made that optimization a little bit more difficult. Regional optimization, I would argue, transcends time. What we do today matters. What we do to our environment, whether it be depleting resources or enhancing them, dramatically affects the future, just as the past dramatically affects the present. Once you get rid of a species or a resource that can't be replenished, it's gone forever. Another way that regional optimization is able to transcend time is biogeographically. When there's a landmass that's once united that becomes segregated, the species that once existed as a contiguous, homogeneous whole are now separated and undergo adaptive radiation, which has dramatic effects on evolutionary biology. Those are just two examples of how regional optimization is able to transcend time. So keep that in mind. What you do today matters. Question number 2 on the midterm is identifying the tension zone, which is an imaginary line that goes from Muskegon to Saginaw that basically divides the climate, soil, and vegetation in the state between the northern and the southern. So climate to the north tends to be cooler, whereas climate to the south tends to be a little bit warmer. To the north, you have a little bit of a shorter growing season, whereas to the south it's a little bit longer. A little bit harsher winters are experienced in the north and a little bit more mild to the south. There are a few exceptions along the border where we have our lake effect snow here where we border Lake Michigan. For the most part, though, this is a very distinct transition. Soil is notably more coarse and sandy and acidic to the north of this tension zone, whereas to the south, it's a little bit more basic and loamy. And we'll discuss why that is in the next slide. Vegetation to the south is primarily deciduous, whereas to the north there's a mixture of hardwoods and conifers. Now, what's very important to understand about this transition and tension zone is that the climate, soil, and vegetation all affect one another. The soil affects the vegetation affects the soil, the climate affects the soils and vegetation. It's all interconnected. It all plays on one another. So I just want to touch very quickly on the soils, the climate, and the vegetation. So the soils, the youngest ones in Michigan are about 16,000 years old. The deposits, the soil consistencies are varied throughout the state based on the receding patterns of the glaciers. What composes the soil in Michigan are secondary to the parent materials that were taken from the eastern to central Canadian shield. The vegetation affects the soil. Limestone and dolomite contribute to the basicity in the lower portion of the tension zone. Flora and deciduous trees recycle base-rich litter more greatly in the lower portion of the tension zone than in the upper. Fauna affects all of these things. It's all very important to understand. Climate is affected by several things. Proximity to the Great Lakes, as we all know, we have the lake effect snow, the lake effect weather. Latitude, distance from the equator can affect temperatures, heat accumulation. Heat accumulation is typically higher to the south of the tension zone and lower to the north of the tension zone. Moisture and evapotranspiration are affected. Evapotranspiration is typically higher to the north of the tension zone and lower to the south of the tension zone. Vegetation is affected by soil composition. It can affect how minerals are transported through that soil, how they're recycled, leaching. Climate affects the vegetation. Vegetation can affect drainage, etc. So basically, the main point here is that they're very distinct, two distinct northern and southern zones that run from Muskegon to Saginaw. It's an imaginary line that divides it, and that they're all interconnected. The third question on the midterm is discussing the plasticity of ice and why it's important to our state. So as we know, as snow accumulates over long periods of time, it becomes firn. Firn becomes dense and turns into ice. That ice is very plastic and malleable. Like when you shuffle a deck of cards, it bends in the middle. And why this is significant is because when the glacier gets over 200 feet in thickness, that glacier is then able to move across the landscape. And that movement across the landscape is significantly important to the landscape. It can flatten the landscape. It can deposit soils and minerals. It can turn up the soils. It can transport big boulders. It can carve out river valleys. When that ice glacier becomes less than 200 feet in thickness, it can halt or recede even. That halting and receding and continued progression is what formed our state, is what gave Michigan our mitten shape. When it halted, it allowed deposits in the lower peninsula, significantly in the lower peninsula, to accumulate. Also, when it melted, it carved out river valleys, eventually forming the big lakes. One more very important aspect before I move on is the rebounding effect that is occurring when the mass of the glacier presses and depresses the landscape. Okay? When it starts to recede, the landscape rebounds. And when that landscape rebounds, it has a dramatic effect on drainage flows, soils, vegetative, spatial organizations, so on and so forth. It's very critically important to understand. So also, it's very interesting to note that the last glacial receded 14,000 years ago, and we're still undergoing that rebound effect. So some byproducts of this plasticity are moraines, lakes, rivers, mineral deposits, soil changes, and even economic influences. Where most of our population is in Michigan is all affected by the plasticity of that ice in the glaciers. Finally, mineral sources vary between the upper and lower peninsulas. This is very important to understand. The Upper Peninsula has large copper deposits and iron deposits and were formed through igneous and metamorphic processes. The iron ore and copper were formed from two different processes. I'm just outlining these two because they were very important. Not that the granite and the greenstone and the limestone and the dullstone aren't, but there's not a significant limestone and dullstone population in the Upper Peninsula, and these copper and iron were very important economically, so I just want to quick touch on them. The iron ore was formed in the early Proterozoic seas and then had to be oxidized in the Upper Peninsula. The copper was formed during the Mid-Continent Rift System. As you go from the eastern to the western Upper Peninsula, you shift from a sedimentary to a more crystalline bedrock. In the Lower Peninsula, you have gypsum and halite, which are sedimentary processes, which were formed by sedimentary process. You also have dullstone, limestone, and then in the Michigan Basin, you have coal. You have so many different things. A lot of this is due to where the parental material deposited from glaciation. Not all glacial deposits were created equally. The Lower Peninsula has a lot more glacial deposits than in the Upper Peninsula. It's more thin, which results in the different soil compositions and mineral deposits that we see. It's also very important to note that these different mineral composites and were formed from different processes a lot of times, and come out of different eras, different epochs that formed these different things. So that's very important. I think I'm out of time, so I'm going to have to wrap it up and say thank you for listening and have a wonderful day.